How are you tonight?
Hi. I'm okay.
You sending me stuff, or you gonna verbalize it?
I'll verbalize it.
Okay.
Alright. So, there's just a couple more things for tomorrow's test.
All right.
Are you ready?
Uh-huh.
Okay. First one, graph each logarithmic function, and it's y equals 3 plus log x.
Okay. What's the elementary function?
It's y equals 3.
Actually, it's this part. They're trying to throw you off by putting a 3 in front.
Okay.
In other words, this is the same thing as y equal log x plus 3, which is the way a vertical shift is more typically shown. But
Okay.
the
Yeah,
associative property holds, so remember what the log function looks like?
Yeah.
It is, incidentally, one of the flattest functions there is. You have to go 2 miles on the x-axis to rise by 12 inches on the y-axis.
Wow.
I know, pretty amazing.
Wow.
And they always go through that point, which is
3.
well, in this case, with the elementary function, that point is always 1, 0. The reason being is that the log of 1 is always 0, no matter what the base. The other thing about the log function that's worth mentioning is that it is the exact inverse of the exponential function. And by that I mean it is a pure reflection about the line y equal x.
Oh.
That's what inverse functions are. Every inverse function that you have ever talked about or will talk about is a reflection about that line y equal x, which is worth knowing.
Okay.
Because it helps with the shape, because that means the shape is exactly like an exponential function, only an exponential functions always go through this point, which is 0, 1, the elementary function.
Okay.
Okay? So, what are we doing to this function? What are we doing to the elementary function over here?
We're moving it up 3.
Yeah. It doesn't change the vertical asymptote. Still is a vertical asymptote there, but it does change that point. 1, 3. So it now and I know what that point is. I'm not sure what your teacher is going to want. 1 point, 2 points, always x-intercepts? What do you think?
She'll probably want 3.
Okay, 3 is a little hard with logs. It's not hard, it's just, in other words, there's nothing very interesting with the log function. Notice there's no peaks, there's no valleys. We'd like to know maybe where it crosses the x-axis, and this point is useful because that's our standard reference point that we moved up 3. So how would we figure out where it crosses the x-axis?
plug in x is 0, or y is 0?
Y of 0. In other words, it crosses the x-axis when y is 0. So solve that.
Okay.
So I've got the log of x equals -3. How do I solve that?
I don't know.
Well, it's log base 10 because it's not stated. So it's 10 to the third power.
Are you just switching it over?
Yeah.
Okay.
In other words, when you have it in log and the variable is in the argument, you don't really have anywhere to go with that. So the only way to solve it is to switch it to exponential expression. Excuse me, 10 to the -3 is equal to x. So this thing crosses the x-axis when x is 1 over 1,000. Very close to the y-axis. All right. What else you got?
Y equals log parentheses x minus 5.
So there's our regular log x. What's happening here with the x minus?
It's going down 5.
No, that's a horizontal shift. In other words, this is of the format x minus h. So it's moving to the right by 5 units. And what are we going to move to the right by 5 units in order to graph it?
The original.
We could move this point. We're going to have to move that point for sure. But the most important thing to move 5 units is the vertical asymptote. Where's the vertical asymptote now?
0.
So it's got to go over to 5. And then our new curve is going to go like that. And what is this point?
That'll be 6.
And we can check that quite easily by plugging in 6 for x and seeing if y is equal to 0. Well, when you plug in 6 for x, you take the log of 1, and that's always equal to 0.
Okay. Ready for the next one?
Uh-huh.
This one says, write each expression as a single logarithm.
Okay.
The first one is log r minus log t plus 2 log s.
Okay. Do you know how to do these?
I kind of do, but they get confusing when there's 3. I know how to do just 2 of them, but when there's 3.
Okay, let's list our 3 rules. If I had a c in there, then it would be plus log c.
Okay.
Okay? And of course, second one is log a over b equals log a minus log b. And perhaps the most important one, at least when you get to calculus, is this one. It's used a lot in calculus. So we're compressing these. In other words, you have to know these backwards and forwards, just like most math things. You need to be able to go this way, which is called expansion, or you need to be able to go this way, which is compression. And since they want you to represent this with one log expression, we're compressing.
Mm-hmm.
So it would be the log of what?
Well, since there's subtraction, so it might be r divided by t times s.
Something. R divided by t is correct. And it would be, the first thing we really should have done was move this 2 to the exponent of s. Because that's the answer. And if you wait and move it afterwards, it's not quite as clear that it's supposed to be s squared. But you can always take that. In other words, this expression right here is the same as the log of s squared, based on Rule 3. Okay? So let's erase those rules, because I think you know them. What's the next one?
The next one is 40, 49. Says expand each logarithm.
Okay.
It's log base of b, so just a b down there in the base. Parentheses 4mn, close parenthesis, power of 5.
Okay, what's the first thing we want to do to expand it?
Well, I know it's gonna be adding.
Right, but we've got this exponent here. So the first step, I think, you got two choices. You could apply the exponent to each of the terms, or you can immediately bring it down and put it in front like this, which I think I prefer. It's going to give you the same answer. Okay, so now we're going to have 5 log base b of what?
M.
Well, what happened? We've got the 4. It's 4 times m times n plus, and this 5 needs to be either like this, or I can put the 5 in front of each one, and in other words, distribute it. And if it ever becomes confusing as to which to do, then look at the problem a different way. If we apply that 5 first, we're going to have a 4 to the 5th power. We're going to have an m to the 5th. So this is definitely correct, because that turns back into m to the 5th, and this turns into n to the 5th. And this turns into 4 to the 5th. So, and then I suppose, no, this is probably the answer they want. The only different answer might be if they put parentheses around it and took the 5s out from inside the parentheses. And in that way, either one is legit.
Okay. Alright. The next one is another expanding one.
Okay.
And it's log base of b, and then kind of x, y, in the parentheses to the power of 4.
Like that?
In the out of the and then the xy to the power of 4, all that is divided by 2.
Like that?
The outside. No, the outside. The whole thing. Yeah, there we go.
Okay. And the 4 does not act on the 2, correct? In other words, it wouldn't unless the 2 is in the parentheses. You said it wasn't. So the question I guess I have to ask here is the 2 part of the argument of the log, or is it the log of this all divided by 2 like that? And that would be
exactly how you have it right now.
Right now?
Yeah.
Okay.
Right now.
So I'm going to assume it's part of the argument. So, yeah, that would make sense. Okay. So this time, I think it actually makes sense to apply the 4 before doing anything, like that.
Okay.
Now, let's expand it. We're going to have the log. And incidentally, when you expand and contract, it always has to be same bases. You can't switch bases. You can't go from like base 3 to a base 4. So what's the first term going to be?
X, or, I mean...
Yeah, if you're fully expanding if you're fully expanding it, you need to move to 4 to the front. Okay. Plus
4 log, and then y.
And the last part?
And then I'm guessing minus log 2.
Uh-huh. Yep.
Cool. That was so hard.
If they give you any like this, well, in fact, I'll give them to you. Expand that.
One x to the 1/2 power.
Uh-huh.
Is that what I need to do?
Yeah. You need to convert those radicals to exponents. Exactly. Precisely.
So 1/2 log to the x minus 1/2 log to the z.
Uh-huh. Okay.
Okay.
That's about as complicated as they get, really, is when they throw radicals in at you. I don't know, unless you have harder ones on there. What else you got?
The next ones are solve each equation, is what it says.
Okay.
And it says 2 minus 4 to the power of x equals negative 62.
Okay. To solve an exponential equation, you usually want to take the logs of both sides. This is a particularly unique one in that we don't really need to do that. Let's isolate and solve 4x equals something. So what does 4x equal? 4 to the x, I meant.
Negative 4 to the x or just 4 to the x?
Well, it'll start out being negative, and that'll be negative 64. and then we'll divide both sides by -1 to turn it positive. In other words, we can solve this without logs. What is x?
4 to the, is it the third?
Third power, correct. Okay, so we don't need logs to solve this. Let me change the problem one tiny bit, and now we need logs to solve it. How do I solve this equation?
You put the, is it natural log or
I always use natural log.
log?
Well, some people might use log base 4, but that only presents problems because then you have to find a change of base formula and everything else. So I always just use natural log. It's the ratio, they'll end up being the same anyway, but you have to do it at both sides. The beauty of that is it allows you to bring the x down on the algebra line. And now I got it solved.
And that's done on the calculator.
Yes.
Right?
Whenever you have to use logs to solve it. In other words, you have to take the log of both sides almost whenever your variable is an exponent, because we don't have algebra for solving that. I mean, we could solve it when it was 4 to the x equals 64, only because they were perfect numbers. But the moment they're not perfect numbers, we don't have algebra to solve this. We only have logs, and logs are tables, basically, in a calculator. When I went to high school, there were tables in a math book. That's how you looked up logs. They didn't have calculators that had log functions. All right. We had to look up logs and trig functions. All were tables in books. Yeah. What's the next one?
That would suck. Log base of 3, parentheses, x plus 1, close parenthesis, equals 4.
Okay. How are we going to solve this?
First, divide by, no, change it to exponential.
Good.
So that'd be 3 to the power of 4 equals log x plus 1.
No? You're changing it to exponential.
Oh, right.
When we're in exponential, we don't have any log anymore. In other words, these two are identical. Just this is exponential and this is logarithmic form of it. So 3 to the 4 is 81 equal x plus 1, x equal 80.
That was pretty easy.
Yeah.
All right. Next one is e to the power of x divided by 4 equals 5.
Okay, what do we need to do to solve this?
Whoa, I don't know.
What is the key about this different than any other algebraic equation? And it's not the e. E is just a number. E is not a variable. What's different about this is the variable is in the exponent. When the variable is an exponent, we don't have any algebraic way of solving it.
Okay.
And that's where you take the log of both sides. Now what's the next step?
Put the exponent in front of the log.
What's the natural log of e? See what I did there?
You subtracted.
No, I multiplied both sides by 4.
Oh, okay.
Okay?
Oh, yeah,
Now,
I see.
notice that that is also the same thing as that, which is the same thing as that. So if I wanted, I mean, simplification is really, I don't know what your teacher wants. I'm guessing that they'd accept that for sure. I'm sure that they would accept that, and they would accept that. So probably you want to make sure that they'll accept that kind of answer.
Okay. Next one is log 4x equals -1.
Okay. First step.
The first step is put exponential.
Okay.
So it would be 10 to the -1 power equals 4x.
Okay. What's 10 to the negative? What's 10 to the -1?
10 to the -1 is just 10.
It's 1/10. It's 1 over 10 to the +1. That's what the negative exponent means. Doesn't mean anything about negative numbers. It merely means take the reciprocal to the positive exponent. So 10 to the -2 would be 1 over 10 squared.
Okay.
Okay. Now we have that equals 4x. So what does x equal?
Divide 1/10 by 4.
Okay.
That would be
What's the fraction?
1/40th.
Yes, 1/40.
Okay. Let's see.
We just doing a half hour tonight?
Yeah.
Okay. Got time for another problem or two?
Alright. Probably only have to do one more. So that makes sense.
Okay.
Let's do a...
Do you have any hard log equations? We haven't done a log equation that I suspect you're probably going to have to do, where you come up with 2 answers and one violates the domain. Do you have any like that?
I don't think we are doing that yet, just because this is the test review.
Okay. So you have nothing that looks something like this would be. In order to solve this equation, I first have to put that into one expression. Then 10 to the 2 equals x squared minus x. 10 to the 2 is 100. So I have x squared minus x minus 100 equals 0. Solve that quadratic. Throw out the negative solution because that will violate that domain, because you can only take logs of positive numbers. So that's...
Well, there is one on here that looks kind of similar.
Okay, let's look at it. I'll tell you if it is.
It's natural log of 2 plus natural log of x equals 4.
Yeah. You're absolutely right. The way to solve this is to make one log function. In other words, we don't really have a way to solve it if we don't do that. I mean, that's a number, so I suppose I could turn that into the number, move it over there, and then put it in exponential format, solve it that way. But that's not the best way to solve it. The best way to solve it is to make it the natural log of 2x equal 4. Now, what?
Okay. Then, do you put it in exponential?
Yep.
Okay, then it would be, well, natural log doesn't have a base, does it?
It's e. It's always e.
Oh, so then it would just be e to the power of 4 equals 2x.
So x would be e to the power of 4 divided by 2.
Ah, okay, that's easy.
Yeah. Yeah, just remember when you're solving equations, and well, kind of try to remember that whenever you see that, probably the answer is going to be to compress it. If you see multiple log expressions being added and subtracted, most likely you're going to have to compress it into a single expression and then convert it to exponential form.
Mm-hmm.
All right.
Okay.
Sounds good, Caleb. Good luck.
Thank you for all your help.
You're welcome. Talk to you next time.
Okay.